Module 8, Stoichiometry, Relating Products to Reactants in Chemical Equations. Now that you have had some practice analyzing chemical equations, we can use them to help us figure out the amount of a reactant that is needed in order to make a specific amount of product. Let's say you were asked to make exactly 2 moles of iron chloride, FeCl3, and you had to do it using this reaction. 2 iron titanium oxide solid plus 4 hydrogen chloride liquid plus chlorine gas produces 2 iron chloride aqueous plus 2 titanium oxide solid plus 2 water liquid. How many moles of each reactant do you need to make exactly 2 moles of iron chloride? Well, that is easy if you have this balanced chemical equation. It lets you know that 2 moles of iron titanium oxide react with 4 moles of hydrogen chloride and 1 mole of chlorine to produce 2 moles of iron chloride, 2 moles of titanium oxide, and 2 moles of water. So your answer is 2 moles of iron titanium oxide, 4 moles of hydrogen chloride, and 1 mole of chlorine. You need these reactants in exactly these amounts. If you only had 1 mole of hydrogen chloride, you would run out of it before you could make enough iron chloride. It would limit how much of the products you would have. But if you had 5 moles of hydrogen chloride, you would produce the desired amount of iron chloride and have a whole mole of hydrogen chloride left over. The other 2 reactants would be used up. So we can use stoichiometry to relate the amount of product we need to the minimum quantities of reactants we need. Here's an example. A chemist wants to make ether, which is C4H10O, for a medical anesthetic. He uses the following reaction. 2 C2H6O liquid plus H2SO4 liquid produce C4H10O gas plus H4SO5 aqueous. If the chemist needs 134.9 moles of ether, what's the minimum number of moles of C2H6O and H2SO4 that he needs? Well, we just need to relate the amount of a product to the minimum quantities of each of the reactants. So we need to figure out the relationship between the quantity we are given and the quantities we need to know using the chemical equation. We first can say that 2 moles of C2H6O equal 1 mole of C4H10O. See the relationship in the given equation here? And we can use this relationship in a conversion problem using the amount given to us. What do we have? 134.9 moles of C4H10O placed over 1. Set up the mole relationship so moles of ether cancel and multiply through to get 269.8 moles of C2H6O. We can do the same thing with sulfuric acid. The relationship between it and ether is 1 mole of sulfuric acid equals 1 mole of ether. Again, I just got this relationship in the given equation above. When we set this conversion up, we get 134.9 moles of H2SO4. So we can say that in order to make 134.9 moles of ether, a chemist needs to have at least 269.8 moles of C2H6O and 134.9 moles of H2SO4.